This is a video presentation of Chapter 8, Section 8 in the 8th grade textbook entitled Surface Area of Pyramids and Cones. So yesterday we took care of surface area of prisms and cylinders. So now we get to our other two shapes, pyramids and cones. And just like we saw yesterday, these are grouped together because they share the same formula for finding the surface area. Surface area here is explained with B plus L. Of course, those are both things that we have seen when dealing with the different formulas. B has shown up a lot. B is the area of the base, and L is the lateral area. Now we can get a little bit more specific with these formulas here as we work into the shapes, but for now, let's go ahead and take a look at the definitions. Slant height. Slant height is the distance from the base of a cone to its vertex measured along its lateral surface. The distance from the base of a cone to its vertex measured along its lateral surface. So what they're saying there is it's the height up up the side rather of the cone. If you were licking the side of your ice cream cone, that distance there from the very bottom of the cone to the top would be the slant height. We also have the slant height in a pyramid there. That's the height up one of the triangular pieces, which is different from the regular height because the regular height goes from the tippy top straight down to the middle of whatever that piece is at the bottom. All right, a regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are all congruent. Pyramid whose base is a regular polygon and whose lateral faces are all congruent. So a couple different things they got here. They got regular in here. Remember, regular implies that the sides are congruent and the angles are also congruent. So, for instance, the base there, if they're talking about a regular pyramid, could be a square. Because in a square, the four sides are the same and the four angles are all the same because they would be all right angles. It could be an equilateral triangle, because in equilateral triangle, all the sides are the same, and by force, all the angles are the same. What it could not be is it could not be a rhombus, because in a rhombus, yes, the sides are the same, but the angles are not all the same. It could not be a rectangle, because yes, all the angles are the same, but the sides are not all the same. Anything that's not regular isn't going to fit into the definition of regular pyramid. Now, when they're talking about the lateral faces being congruent, they're talking about the triangles. So what they're saying is all the triangles on the pyramid, the sides of the pyramid, all have to be exactly the same triangles. They can't, one's not going to be a right triangle and the next one's going to be acute. All right, that's not going to work. The triangles all have to be the same. They could be right, but they'd all have to be the exact same right triangle, and I have to admit that would probably be a rather odd regular pyramid, but the definition, it does fit. And then they've got right cone. That's a cone in which a perpendicular line drawn from the base to the tip, the vertex, passes through the center of the base. So what they're saying there is if I drop a line down from the tippy top of the cone to the very bottom, or if you were talking about your ice cream cone from the very bottom, the way we would think of it, straight up, it would hit to the middle of that circle, exactly to the middle of the circle. So if you go and melt the funnel that you dump the oil to in your car, it's probably not going to be fitting that definition of a right cone anymore, because chances are that tippy top is not going to line up with the center of the circle, so that would not fit the definition. But if it drops down and hits the exact center of the circle and makes that right angle that they talked about, perpendicular line, that will be a right cone. All right, so let's go ahead and take a look at the examples here and start looking how we can use that B plus L formula. In question number 1, they're asking us to find the surface area of the figure to the nearest 10. And obviously that shape is a pyramid, so we want to make sure we use the pyramid formula. Now, notice the pyramid formula that's presented there is a little bit different than that B plus L formula that I read earlier. What's probably even more confusing is that there's an L there that's not the same as the L as the formula I gave you. Lowercase l, that cursive lowercase l there, that is actually the slant height. And we talked about the slant height in the definitions. It's different than the regular height. The slant height is the height of the triangular piece right here. Right, this distance here, this dashed line that you see on the right side of the image is the slant height. Okay. Just to point out how it's different, not that you need it in this one, but the regular height would be dropped down from the tippy top of the pyramid and drop down until it hits that piece that's at the bottom there. That actually would be the regular height. But again, that's not in the formula, so we don't really have to worry about that. All right, let's see what else is in that part that they've changed there. They've got half and P in there. P we saw a little bit of yesterday. P is the perimeter of the base, the perimeter of the part that's at the bottom. Well, as you can see here, the sides are marked 2.4, which means all the sides are 2.4, so you're going to do 2.4 plus 2.4 plus 2.4 plus 2.4 there, which as you can see in the calculation here has changed into 9.6. The bottom piece here, or the B piece rather, 2.4 times 2.4, they're finding the area of the base. That guy has not changed. Which is what you're seeing right here. Obviously, this piece down here, then the implication is that is a square. That would be how it would be regular shape, with that being a square. And it couldn't be a rhombus. And if you think about it, putting a rhombus at the bottom of the pyramid would make some awfully odd triangles that probably wouldn't go together very well, which probably helps explain it even better than anything else I could say why that is a square. The reason that changes there is described on page 436 in your textbook. The lateral area there is 1/2 the base perimeter, which is called P, times the slant height L. Again, that's on 436 in your textbook in the box there. They say that L, which I gave you in the original formula that we wrote when we did definitions, the lateral area, uppercase L, is 1/2 the base perimeter, which is called P, times the slant height L. And that's exactly what we changed that into. And when I say slant height L, that's lowercase l. Again, I know a little confusing, but work with it. All right, so we're solving now here, order of operations. So you got 2.4 times 2.4 on the left there, and the half times the 9.6 times 3 on the right. And then you're going to add those guys together, and you end up with 20.16 feet squared. All right, let's continue on with number 2. Cone has a diameter 8 inches and a slant height 3 inches. Explain whether tripling the slant height would have the same effect on the surface area as tripling the radius. So this question is similar to what we saw yesterday. Take off of the volume questions that we saw before the final exam. Remember, those though were asking me if tripling triples the same way as it would to the answer, where here they're asking me does tripling do the same thing compared to each other. A little bit different. So first thing we need to talk about is the formula, how that changes up there. Notice they've written there pi r squared plus pi rl. Pi r squared is equivalent to the area of the base, the circular piece. We know pi r squared is the area of a circle formula, so that makes good sense to us. And that uppercase L, the lateral area, ends up changing into pi rl. And again, that's described on 436 in your textbook. The lateral area is 1/2 the base circumference, 2 pi r, times the slant height L. Right? And that's what they're doing right there. Now you're saying, well, wait a minute, you said 1/2 and then 2. Well, think about it. 1/2 times 2 is going to go to 1 by itself. So that leaves behind the pi, the r, and the L, which is what you can see there substituted in for uppercase L that we originally wrote. So we were told that the radius was 4 and the slant height was 3, and so we can go ahead and look at solving here. So we've got pi times 4 squared plus pi times 4 times 3. Notice again they're back to writing our answers with pi. So this is 16 pi over here on the left and 12 pi here on the right. Well, 16 pi's and 12 pi's make 28 pi's, which is this answer right here. And then 28 times 3.14 is 87.9. All right, so now let's experiment with the couple tripling pieces here that they've asked us to mess around with. Let's start off with tripling the slant height. So we're going to triple the L number here. The L number that they gave us here was 3, so that's going to change into 9 in the formulas. So the R's are going to stay the same. So this left side looks exactly the same, and the front part of this looks exactly the same, but L here changed into 9. Notice it says 3L here because they're tripling it like they said. So simplify. This is 16 pi's over here, and this is 36 pi's over here. And if we put those together, that gives me 52 pi's. So 52 pi, and that's inches squared. 52 times 3.14 is 163.3 inches squared. All right, now let's come over here and triple the radius and see if we get the same answer or not. So now I'm going to triple that R number, which we figured out was 4. Remember, that came from the fact that the diameter is 8, cut it in half, and the radius must be 4. So 4 times 3 is 12, which is where this came from. That's my tripling. Square it, that's 144, so this is 144 pi. 12 times 3 is 36, 36 pi's. 144 pi's plus 36 pi's gives me 180 pi's. 180 pi's is the same as 565.2. Well, as you can see now, tripling the radius and tripling the slant height does not do the same thing there. So that would be the answer to our question. I think you've probably figured out from yesterday and today the difference is that square. Squaring the radius actually gives you a bigger answer versus just changing the slant height, which is not squared. That's how we generate the difference there in the two answers and why they're not working out to be the same, even though we're doing the same thing, in this case, tripling. All right, let's go ahead and take a look at number 3 here. The upper portion of an hourglass is approximately an inverted cone with the given dimensions. What is the lateral surface area of the upper portion of the hourglass? All right, so if we go back to our formula, remember what they said here when they talked about cones is that the lateral area is the same as pi r L. And when I say L, I mean lowercase l, the slant height. But if you take a look at this question, that's the one number we don't have. We don't have the slant height. The height up the side of the cone, we just have the regular height. All right, so we obviously need to find that. But notice what we do have. If we look at the dashed lines there and the little angle marker, we have something rather interesting. We have a right angle. And if we look at this lateral slant height, rather, that we're trying to find, I actually have a right triangle. And if we have two sides of the right triangle, that means we can use the Pythagorean theorem, or the Pythagorean formula, to find the missing side. Remember, what that formula says, if I square this guy and square this guy and add them together, and then take the square root, that'll give me this side, which is the hypotenuse, which is also my slant height, which is what I desperately need to find the surface area. So let's go ahead and do that. Take my two numbers, my 10 and my 24, and square them. This is 100, this is 576. Add them up and that's 676. Now remember, in order to make the theorem or formula work here, then you've got to take the square root. So you're going to take the square root of 676 and you get 26. And that's my missing number here. This side measures 26. And once I have that number, now I have everything I need to find that lateral surface area. Now again, I'm not finding the whole surface area, I'm just finding the lateral surface area. And if you're having problems with that, again, look at the formula on 436 in your textbook. It even tells you the lateral area is 1/2 the base circumference, 2 pi r, times the slant height L. All right, or in other words, pi RL. So pi, which is 3.14, times the radius, which is clearly marked 10, times the slant height, which I just found, which is 26. Well, that's the same as 260 times pi, or 260 times 3.14, which is 816.8. Now, I want to make sure you understand also what you just found. What you found is the surface area of this cone piece here, actually. All right, going around that way. Not the circular piece at the top. All right, if this was some type of strange can at a grocery store that was closed off and that was the lid, you wouldn't be finding the surface area of that based on what you just did. You only found the surface area, or the area, if you want to think of it that way, of this piece down here, beneath the circle, the way this is drawn. All right, let's go ahead and finish this off here with the check it out example, where we're finding the surface area of the figure to the nearest tenth, and obviously that shape is a cone. So cone formula is essential here. Pi r squared plus pi rl, lowercase l. So I need r here, which is clearly marked 7, and I need my l here, which is marked 18. So it's 3.14 times 7 squared plus 3.14 times 7 times 18. And that's just me plugging in the numbers. Wherever I see an r, changed it into 7. Wherever I see an l, changed it into 18. So over here, this is the same as 3.14 times 49. And on the right side there, 3.14 times 7 times 18 can be solved right away. No order of operations necessary, really, because there's nothing like a square getting in the way. That's going to change into 395.64. And we'll do one last simplification on this 3.14 times 49. Again, I'm making sure I apply the order of operations there. That's 153.86. And I add those guys together for an answer that's estimated at 549.5, rounded to the nearest 10.